Hey everyone, welcome! Today, we're pulling back the curtain on one of the most elegant, most essential tools in programming, the stack. It's a really simple concept that's secretly the engine behind so much of the technology we use every single day. So let's dive in and see how this simple little idea organizes our entire digital world. Seriously, have you ever just stopped to think about that? How does your computer know exactly how to reverse its actions so perfectly? It feels like some kind of digital magic, right? Well, it's not a spell. It's a beautifully simple data structure. And understanding it is the key to everything we're talking about today. So the solution to this really complex memory problem is actually found in a surprisingly low-tech place. A cafeteria. Yeah, a cafeteria. Just picture one of those spring-loaded plate dispensers. This one powerful metaphor is pretty much all you need to understand the heart and soul of a stack. And that brings us to the stack's one golden rule: last in, first out, or as we call it, LIFO. This principle governs every single thing a stack does. And you know what? It means exactly what it sounds like. The very last thing you put in is the absolute first thing you have to take out. Honestly, the source material just hits the nail on the head with this quote. Think about it. When you put a clean plate onto that dispenser, it goes on top. The next person in line, they don't try to dig down to the bottom for an older plate, right? No way. They just grab the one that was just placed there. The last one in is the first one out. So let's just boil this down to 3 super simple rules. Rule number 1, you add plates only to the top. Rule 2, you take plates only from the top. And that means rule number 3 is just a given. The last plate you put on is always the first one you take off. That's it. That is the entire logic of a stack. Okay, so we've got that cafeteria idea down, right? Now, let's get a little more technical. Let's translate those simple actions, adding and taking plates, into the formal operations that programmers actually use to control a stack. All right, let's walk through this. Imagine we have a brand new empty stack. First, we push element A onto it. Boom, there it is. Next, we push B. It goes right on top of A. And then we push C on top of B. Okay, so now what if we want to take something off? We use the command pop. And here's the cool part. You don't tell it what to remove. It only knows one move: take from the top. So C is gone. And if you just want to, peek at what's on top without actually taking it, that's the top operation. We do that and it'll tell us, hey, B is at the top now. And that's really the whole shebang. Push adds, pop removes, always from the top. It's so simple, so predictable. And that predictability, that's its superpower. That's what makes the stack so incredibly fast and efficient. All right, this is where it gets really fun. Let's take this abstract idea out of the textbook and see where these stacks are hiding in plain sight, in the software you literally use every single day. Just check out this list. Every single time a program calls a function, that function gets pushed onto what we call the call stack. That undo button you can't live without in your text editor? Yep. Every time you click it, you're just popping your last action off a stack. Your web browser's back button? It's just popping URLs off a stack of pages you visited. I mean, once you see the pattern, you can't unsee it. It is truly everywhere. And this brings us right back to where we started. Remember that big question we asked at the beginning about how a computer traces its steps back so perfectly? Well, the magic, the secret sauce, is the call stack. Every time a function gets called, it's pushed onto the stack. And as soon as that function is done doing its thing, it gets popped right off, and the program knows exactly where it was before, whatever is now at the top. Okay, let's watch this in action. Your main program kicks off. Push, it's on the stack. Then main calls function A. Push, function A lands right on top. You guessed it, function A calls function B. Push, there's function B at the very top. Now watch this. Function B finishes its job. Pop, it's gone, and control snaps right back to function A. Then function A is done. Pop. And just like that, we're back in main, right where we left off. It's perfect, predictable. Last one in, first one out. All right, there's one last big idea we need to cover. See, we've been talking all about what a stack does, but we haven't really talked about what it's made of. And that's because, well, a stack is really more of an idea, a blueprint, than one specific thing. This idea has a name. It's an abstract data type, or ADT for short. And an ADT is basically just that, a blueprint. It tells you the rules of the game. It says, hey, push has to add to the top and pop has to take from the top. But it doesn't say a single word about how you actually build it. For instance, you could build a stack using an array, a simple block of memory. Or you could build one using a linked list with all these nodes pointing to each other. They have different trade-offs, right? The array is fast but has a fixed size. The linked list is super flexible and can grow whenever you need it to. Internally, they're totally different beasts. But, and this is the important part, because they both follow that one golden LIFO rule, they are both 100% valid stacks. And really, that's the thing to remember. What makes a stack isn't what it's made of, it's how it behaves. As long as it plays by the last-in, first-out rules, it is a stack, period. The rest is just an implementation detail. So the stack is really proof that sometimes the simplest ideas are the most powerful ones. It's this tiny fundamental building block that makes our huge, complex digital world even possible. And that just leaves me with one last question for you to chew on. Now that you know the pattern, what other parts of your digital life do you think are secretly being run by this simple last-in, first-out idea?